I'm Lakshya and now let's start with physical science. As it best starts, here you have the multiple choice question answers. Now let's start with it. The first one, the color of middle orange indicator in acidic medium is, the options are option A yellow, option B green, option C orange, option D red. Clear? Now let's start with it. The color of methyl orange, actually methyl orange is an orange color. Okay, methyl orange is orange in color. Now here, if methyl orange indicator in acidic medium is, so here methyl orange indicator, if it is mixed with acidic, then it turns into red color, guys. Okay, if methyl orange indicator is mixed with acidic medium, it turns into red color. If methyl orange indicator, if it is mixed with basic medium, it turns into yellow color. Clear? Yellow in color. Mixed with alkaline or basic medium, it shows the color of what? Which color it shows? It shows yellow color. But here, if methyl orange is mixed with acidic medium, and it shows what? Red color. So here you have the option D will be the correct in the first case. So option D is correct. Let me take. So now here you have the second one. The color of phenolphthalein indicator in basic solution is. So the color of phenolphthalein indicator, if phenolphthalein indicator in basic solution is, so here you have option A yellow, option B green, C pink, D orange. Phenolphthalein indicator, when it is mixed with basic solution, it shows pink color. Phenolphthalein indicator mixed with basic solution, or if any base is if any base is reacted with phenolphthalein. Okay, if I put like basic soap water is base, right? So if I put soap water on phenolphthalein indicator, and the phenolphthalein indicator turns into pink. But if phenolphthalein indicator is mixed with acid, it is colorless. It shows no color. Okay, no color. It is shown no color. It shows no color. So here phenolphthalein indicator with base. Here they asked for base, so then the answer would be pink. Okay, pink will be the correct answer. Next, the color of methyl orange in alkali conditions. So in alkali conditions, the color of methyl orange, as I have said before, here you have the first question we have dealt, where methyl orange in acidic medium is red, and then methyl orange in basic medium, in alkali medium, in alkali conditions, it will be yellow in color. Okay, it takes yellow color. Okay. Now next, clear? Good. Now next, fourth one. A solution turns red litmus blue, its pH is likely to be. So firstly, let's learn pH scale. Okay, firstly let's learn pH scale. Here instead of taking this question, let's solve the question where a solution turns into red litmus paper. If I take red litmus paper, then if this red litmus paper turns into blue, then what is the pH scale they are asking? So this is the question. Firstly, let me write something over here. Let's learn about pH scale. Okay, pH scale. Sorry. Okay. So here in pH scale you would like something like this. Okay, where you have litmus paper. Let's imagine litmus paper. You also look something like this. Now here you have ranges 1 to 14 range. You have the first range over here, 1 to 14 range. Okay. Somewhere you have 7 over here. The range 7 over here, where the range 7 is neither acidic nor basic. Okay, the range 7 is neither acidic nor basic. It means it's neutral. Clear? Now here from 7 coming back to this side. Okay, coming back to the right hand side. Now it will be basis. Okay, it totally comes under basic medium. Basic medium means here it will be base. Where here it will be acidic medium, acid or acidic. Okay, it shows acid over here, but here, like guys, where one coming back to here, one, it turns into very red color. It turns into red in color. Okay, it shows red color. If it is showed red color, it is highly acidic. Okay. Now coming back to here, it shows black. Okay, black color. Here will be red color. Okay. Now here, where if this direction shows strong acids. Okay, this direction shows strong acids, and this direction, if this direction shows weak acids. Okay, this direction shows weak acids. direction shows strong base. On the other hand, this direction shows weak base. Clear? Means strong base means here you have where acids start from 6 to 1, right? Here where base starts from 8 to 14, right? Now what will be the answer? So here you have solution turns red litmus blue. If you have red litmus, if this red litmus turns into blue, then it definitely comes under basic medium. Okay? So if this red litmus turns blue, then it definitely comes under basic medium. So here you have options are 1, option A 1, option B 4, option C 5, option D 10. Now 1, 4, 5 comes under acid because here you have 6, right? 6 is just below. Where below the 6 you have 4, 5, 1, etc. 4, 5, 2, 3, 1. So so first three options are acidic. So then coming back to other one, here you have it will be basic, okay? It will be basic in nature, so therefore D will be the correct answer. Let me mark it with the other one. So where D will be the correct answer because after 8 you will be getting 9, 10, where 10 is the base, as we have learned in the pH scale, according to the pH scale. Clear? Very good. Now let's go for the fifth one. A solution reacts with crushed eggshells. A solution reacts with crushed eggshells to give a gas that turns lime water milky. The solution is off. So here you have option A NaCl, option B HCl, option C lithium chloride LiCl, option D potassium chloride. Okay? KCl. Sodium chloride and HCl hydrochloric acid. So now let's find it. Okay, let me rub this. Here you have a solution reacts with crushed eggshells, guys. When crushed eggshells means the element in crushed eggshells will be CaCO3. Okay, CaCO3. Now let me rub it off. Let's study in detail the fifth one. Here you have the solution reacts with crushed eggshells. Crushed eggshells element, we'll be getting the crushed eggshells element would be CaCO3 plus. The correct option over here is, guys, HCl. Okay, so now let's learn it. So here CaCO3 plus HCl gives rise to, here CaCO3 plus HCl gives rise to CaCl2. CaCO3 plus HCl gives rise to CaCl2 plus CO2 plus H2O, guys. Okay, this is what the equation happens. Okay, this is what I have made an equation where CaCO3 plus HCl gives rise to calcium chloride plus carbon dioxide plus water, H2O. Now here where water means it's a form of liquid, where this carbon dioxide it is in the form of gas. Okay, it evolves like it is in the form of gas. Okay, now here CO2, CaCl2 plus CO2 plus H2O. Now here what happens here is this, by using, now this CO2 is very important here, where when this CO2 is mixed with lime water, when this CO2 is reacted, when this CO2 is mixed with lime water, then this lime water turns milky. This lime water turns milky whenever this CO2 is mixed with lime water, this lime water turns into milky. Okay, the solution turns completely into milky. So here, where by adding HCl, we are getting carbon dioxide. Clear? Yeah. So therefore, the correct option will be BHCl. Sixth one, here you have, if a base dissolves in water, by what name it is better known. Okay, if base is dissolved in water, by what name it is better known. So firstly, where bases mostly they are not dissolved in water, where bases are insoluble in water. If so, however, if base is soluble in water, if so the base is dissolved in the water, then it is better known by options. Here you have option A neutral, option B base, option C acid, option D alkali. It is better known by alkali. Okay, it is better known by alkali. So let's mark it. So alkali is the correct option in the first one. Now the second one, here you have, which of the following substances when mixed together will produce table salt. Table salt means the salt weight. Okay, curry बनाने को use करते ना salt, we use salt for making curry. So that is called as table salt. So which of the following substances, when we mix two substances, which of the following substances will produce table salts? Okay, so firstly, in preparing or in making table salts, we have very two high reactive and very highly reactive elements which involves in this process. So options are: option A, sodium thisulfate and sulfur dioxide; option B, hydrochloric acid and sodium hydroxide; option C, chlorine and oxygen; option D, nitric acid and sodium hydrogen carbonate. Okay, sodium hydrogen carbonate over here. Now the correct option is D, hydrochloric acid and sodium hydroxide. So firstly, where HCl, right? Here you have HCl. Okay, where HCl, let me write down the equation over here. HCl plus sodium hydroxide. Sodium means Na, right? NaOH. Sodium hydroxide means NaOH. NaOH. So when this gives rise to here, where if we add like a HCl hydrochloric acid plus sodium hydroxide gives rise to NaCl. NaCl means sodium chloride, where it is also known as salt. Okay, where sodium chloride is also known as salt. Okay, so it gives us NaCl, sodium chloride plus H2O, water. Okay, where H2O means it's something like water. Okay, so this is what it gives us. Now here, actually guys, we have learned in class 6 the NCERT separation of substances lesson. Now coming back to here, where we know that we have dealt like how the salt is made. Okay, how the salt is produced, from where actually you have few a little very tiny, and mostly in summer seasons this process is happened by farmers. Okay, so what they do is they take armpits. Okay, they dig armpits and they pour all the sea water into these armpits. What they do, they try to pour some water, means sea water. Sea water means mostly salt water. Okay, they try to pour all the salt water into these armpits, and they try so after drying, so if here this water means this sea water is being dried under the sun, so what happens here is the sun is falls on it, right? Then this sun tries to absorb all the water, where H2O, where water is being absorbed in the form of vapor. Okay, so water vapor, it is absorbed, where water vapor is evolved up, where water vapor is absorbed by the atmosphere. So water is absorbed by the atmosphere, so the remaining will be what? NaCl, where here we will be getting, after absorption of all the water, we will be finding a very tiny crystals. So these crystals are salt crystals which are lying on the land. So therefore we will be getting salt crystals. So these salt crystals, they lie on the land. So this is what they take out the salt by using sea water. So, okay, with salt water. So here, which of the following, when we mix this hydrochloric acid HCl, the sodium hydroxide NaOH gives rise to, so this gives rise to NaCl, means sodium chloride. It is also commonly known as salt plus H2O. Okay, H2O in the vapor form, it evolves into atmosphere. Okay, it mixes into the atmosphere. Clear? Now next one, what color would hydrochloric acid pH equals to 1 turns universal indicator? So here they have given hydrochloric acid. So what color would hydrochloric acid turn when pH equals to 1? So here the name itself, it's acid. They're indicating like the name itself, it is acid. Okay, the name itself, it is saying like it's hydrochloric acid. If pH equals to 1, it is highly acidic, guys. If pH equals to 1, then it's highly acidic, means the color turns into red in color. So therefore the acid means it's hydrochloric acid. If its pH equals to 1, then it turns into red in color. So among the given options, orange, purple, yellow, red, so that the red will be the correct answer. Red is the correct option. Clear? Now, the ninth question. Clear with it? Now, yeah. Let's go for the ninth question. Which of the following types of medicines is used for treating indigestion? Option A, antibiotic. Option B, analgesic. Option C, antacid. Option D, antiseptic. Antibiotic, analgesic, antacid and antiseptic. Now here, the correct option is antacid. Okay. Now, okay, let's learn it here. Where after food digestion, okay, where food travels through the food pipe and into the stomach, right? Now, what happens here is the stomach, they try to produce few acids. Okay, this stomach produces HCl, and bile juice is being produced by the gallbladder, so something where few acids are produced inside the stomach. Okay, so now what happens here is these acids are they produce for the digestion, the further digestion of the food in our stomach. Okay, as we know. Now here, this after digestion process, after this food enters into the small intestine, our stomach which is there, okay, our stomach remains acidic. Okay, our stomach remains acidic. So by that, if our stomach is produced more acid, okay, if we take more food into, okay, if we take excess food, if we take heavy food, the stomach will produce more acid for digestion process, right? If we take more food, our stomach also produce more acid. By producing more acid, our stomach our stomach turns into acidic. Turns into total acidic. Now then, that time what happens here is we will be getting few sensations like heartburning sensation, and you have we will say like acid forms into our body. Okay, something like that, where food poisoning or acid forms actually. So for that time what do we do is you will be taking few medicines. We will be taking few medicines which includes antacid. Okay, but these antacids are taken in the form of liquid or medicines. Okay, now here these antacids they act like bases, guys. So what they do, these antacids they act like bases and they neutralize. Okay, this acid and base, they both combine and they neutralizes, means our stomach is now free. Our stomach is neither acid nor base after taking antacid. Okay, this what happens here is this antacid they acts as base and they neutralizes our stomach. Okay, now that time there is no acid will be there. There is no acid will be remain in our stomach. This is what happens. So therefore, I can say that antacid will be the correct option in the process of heating indigestion. Clear? What gas is produced when magnesium is made to react with hydrochloric acid? If magnesium is reacted with hydrochloric acid, then what gas is produced? So this is the given question. Now the options are option A, hydrogen, option B, oxygen, option C, carbon dioxide, option D, no gas is produced. So now let's find it. Here, let's find the solution for it. So here you have what gas is produced when Mg, magnesium means Mg, right? Now let me write down the equation where Mg, guys, magnesium plus HCl, 2HCl, where magnesium is in the state of solid state and this is in liquid aqueous state. So where this gives rise to, where Mg, magnesium Mg plus 2HCl gives rise to MgCl, magnesium chloride, MgCl2 plus H2 plus hydrogen. So therefore the correct option will be hydrogen. Clear? Mg plus 2HCl gives us to MgCl2 plus hydrogen. Hydrogen means H2. So therefore the correct option will be hydrogen. So when if magnesium is made to react with hydrochloric acid, then the gas is produced the hydrogen gas is evolved and the hydrogen gas is produced. Well, this is in the form of aqueous state. Okay, well, this is in the form of aqueous state and this is in the form of gas. Okay, it moves up. Okay, it is absorbed by atmosphere by hydrogen. Clear? Bye.